Hi everyone, for today's lesson we are going to learn how to add, subtract, and multiply polynomial functions. Our I can statement for today is for you to be able to say, I can add, subtract, and multiply polynomial expressions and polynomial functions. The first thing we are going to start off with is adding and subtracting polynomial expressions. First, you're going to see two polynomials that are being added together with parentheses. Be careful, we are adding here, we are not multiplying. So whenever you see addition, all you're going to do is drop the parentheses and combine like terms. So I'm going to take 8t, add 6, minus 5t squared, plus 2t to the third power, minus 3t squared, plus 7. From here, I'm just going to combine my like terms and make sure that my final answer is in standard form, which means that the term with the highest degree is going to go first. In this case, we have a 2t to the third power and no other t to the thirds. So 2t to the third power will be my first term. And just to stay organized or know that I've already used that term, I like to cross it out. Then I have t to the second power, and I have negative 5t to the second power minus 3t to the second power, which is minus 8t to the second power. I only have one 8t, so I'm going to add 8t. And finally, I have 6 plus 7, which is plus 13. I combined all of my like terms, and there's my answer. 2t to the third power minus 8t squared plus 8t plus 13. Next, we are subtracting polynomials. So you'll see two polynomials that are in parentheses with a subtraction symbol on the outside. We distribute that negative symbol to every single term on the inside. Please make sure that you distribute to every term. A lot of kids only multiply the negative to the first term. Please be very careful. So I'm going to drop the parentheses of the first expression, and I have 2y to the third power plus 7y squared minus 6y. Negative times negative is a positive 4y squared. Negative times a positive is a minus 3y. Negative times a negative is a plus 9. Once again, I'm going to combine my like terms, starting with my highest degree term, and that is 2y to the third power. So I'm going to write 2y to the third power. There's no other to the third power, so I'm just going to cross that out. I have a 7y squared plus a 4y squared, so that is plus 11y squared. Negative 6 minus 3, which is minus 9y, and then plus 9. So my answer is 2y to the third power plus 11y squared minus 9y plus 9. That is adding and subtracting polynomial functions. And what's really or polynomial expressions. And what's really cool about polynomials is that you can add, subtract, multiply, and eventually we will get to dividing. But now we are going to multiply, and there are two different ways that you can multiply. The first way I'm going to show you is the box method. The second way is an expanded version of FOIL. I do not care which approach you use as long as you are consistent and you efficiently get the right answer. So the first approach I'm going to show you is the box method. And in this case, we have a binomial times a trinomial. So my box that I will need is a 2 by 3. And on the outside, I'm going to write down the terms of my binomial, and I'm going to write down the terms of my trinomial on the outside of the box. If you notice that something has a minus, that minus goes along for the ride. But if it's positive, we simply write it as a positive term. You do not need to show the plus or the plus symbol. And now what you do is you multiply each term on the outside to each other and put the result on the inside. So I'm going to multiply 3x squared times x to make this 3x to the third power, and then 3x squared times 2 to make that 6x squared. Then I'm going to multiply negative x times x to make it minus x squared, negative x times 2 to make it minus 2x, 4 times x to make this 4x, and 4 times 2, we have 8. So whenever you multiply polynomials, the whole goal is to make sure that every term in the first parentheses is multiplied by every term in the second parentheses. And what's nice about a box is that you have the ability to do that. So along your diagonals, you're going to notice that you will have like terms. So 3x to the third power is my first term. And then I have like terms right here. 6x squared minus 1x squared is a plus 5x squared. I have a minus 2x and a plus 4x, so that's going to be plus 2x. And then finally, plus 8. And there's my result. So that is one way that you can multiply polynomials. Another way is to do an expanded version of FOIL. And that just means that every term in the first parenthesis, once again, is multiplied by every term in the second parenthesis. And we just distribute using arrows as if it was an expanded version of FOIL. And the other thing I'm going to show you in this problem is how to line up your terms instead of horizontally. You can also line up your terms vertically. Here we go. I'm going to multiply x times 6x squared to make this 6x to the third power, x times 3x to make this plus 3x squared, x times negative 5 to get minus 5x, negative 2 times 6x squared is a minus 12x squared, and I'm going to line that up under the x squared term. Negative 2 times 3 is minus 6x, and I'm going to line that up with my x term or linear term. And negative 2 times negative 5 is a plus 10. I create my own column because it doesn't have a like term yet. Now I'm going to put a plus sign and add going straight down. So I have 6x to the third power minus 9x squared minus 11x plus 10. And there is my answer. So that is multiplying two polynomials together. Like I said before, I do not care which approach you personally use, but make sure that you are consistent and you're able to get the right answer. So what I'm going to write right here is that this is another approach of lining up your like terms. And I like this approach just because it takes up a little bit less space horizontally, and it keeps you organized as well. And that tends to be the biggest struggle that students make for these easier problems, is that they're not organized. So this next section is about multiplying three binomials together. So these will all have two terms inside of them. And what you're going to do is you're going to use FOIL, or the distributive property, to multiply two of the three binomials together first, and then you'll multiply the polynomials together. So this is one approach. One approach is to just FOIL the first two together. So I'm going to multiply x minus 3 times x plus 7. So this is x times x, which is x squared, x times plus 7, which is plus 7x, negative 3 times x, which is minus 3x, negative 3 times 7, which is minus 21. Combining my like terms, we end up with x squared plus 4x minus 21. So that is my polynomial that came as a result of multiplying the first two together. So now where I'm at is I end up with x squared plus 4x minus 21 is now going to be multiplied by x plus 1. So from here, you can multiply using a box, or you can multiply using an expanded version of FOIL like we did up here. What I have for this first one is using a box. I'm going to put the binomial terms on the outside where I have 2, and then I have going straight across my x squared, 4x, and a minus 21 where I have 3 columns. Multiplying in x times x squared is x to the third power. X squared times 1 is x squared. 4x times x is 4x squared. 4x times 1 is 4x. Negative 21 times x is negative 21x. And negative 21 times 1 is negative 21. Once again, along the diagonals, you will end up with your like terms. So I have an x to the third power. X squared plus a 4x squared is plus 5x squared. 4x minus 21, that is minus 17x, and then minus 21. That is using a FOIL to box. Another approach is just using FOIL and then an expanded version of FOIL. So in example letter B, I will multiply x plus 3 times x minus 6 and end up with x squared minus 6x plus 3x minus 18. This means I will end up with x squared minus 3x minus 18. So now my expanded version of FOIL, I'm going to multiply x squared minus 3x minus 18 by x plus 5. X squared times x, that is equal to x to the third power. X squared times plus 5 is plus 5x squared. 3x, negative 3x times x is minus 3x squared. Lining up my like terms. Negative 3x times 5 is minus 15x. Negative 18 times x is minus 18x. Negative 18 times 5, that is minus 90. I'm going to add going straight down. So I end up with x to the third power plus 2x squared minus 33x minus 90. And that is my result. So all we're doing here is adding, subtracting, and multiplying polynomial expressions. But polynomials, as we already know, can be written as functions. And we are allowed to add, subtract, and multiply functions as well. So now what I'm going to give you is a bunch of functions, and I'm going to give them different names. This one's f, g, h, and k. And I want you just to perform the operation. I'm going to do for you guys 4, 6, and 8, and you will pause the video to do 5, 7, and 9 on your own. So here we go. Problem number 4. For problem number 4, we are taking h of x and subtracting k of x. So that means that I need to find what h of x is, and in this case, it is equal to 3x squared minus 4x plus 7. So that's what I'm going to write down, 3x squared minus 4x plus 7, and I'm going to subtract it, or I'm going to subtract k of x from it. So I'm going to subtract 8x plus 2x to the second power minus 3 plus 9x cubed. Now, I'm putting these into parentheses because I need to make sure that I'm subtracting every single term from that polynomial. It's very important that you do that. All right, here we go. We have 3x squared minus 4x plus 7. I'm just dropping the first parentheses and then distributing the negative to every single term in the second parentheses. So we have minus 8x minus 2x squared plus 3 minus 9x cubed. Now we need to put it in standard form, and it looks like negative 9x cubed is the the leading term. It has the biggest degree, so I'm going to write negative 9x to the third power. Next, I have a 3x squared minus 2x squared, so that is a plus x squared. Combining my x's, I have negative 4x minus 8x, so that's minus 12x. And finally, I have 7 plus 3, which is 10. And that is my result. Negative 9x cubed plus x squared minus 12x plus 10. So that is subtracting polynomials. Once again, please make sure that whenever you subtract, you use parentheses. Next, we are going to add. So I'm adding f of x, which is, in this case, 4x to the third power, and g of x. So that's going to be the 3x squared minus 4x minus 2. So I have 4x to the third power plus 9, and I'm adding 3x squared minus 4x minus 2. Now, because I'm adding, I can simply drop the parentheses and rewrite this as 4x cubed plus 9 plus 3x squared minus 4x minus 2. I want to put this in descending order or standard form, so I'm going to start with 4x cubed Then I have a 3x squared. No like terms for either of those. Then I have a minus 4x. And finally, 9 minus 2 is 7, so plus 7. So 4x cubed plus 3x squared minus 4x plus 7 is my answer. And finally, I'm going to multiply polynomials. And it doesn't matter if you want to use the box method or an expanded version of FOIL. It just depends on what you personally want to do. As long as you're organized and you're able to get the right answer, that works for me. So f of x in this problem is 4x cubed plus 9. And we're multiplying it with g of x. So that once again is 3x squared minus 4x minus 2. I'm going to do an expanded version of FOIL. So I'm going to multiply 4x cubed times 3x squared. And 4 times 3 is 12. X to the third times x squared is x to the 5th power. Remember, when you multiply two powers with the same base, you add the exponents. 4x cubed times minus 4x squared. Minus 4x, that is equal to minus 16x to the 4th power. 4x cubed times minus 2 is minus 8x to the 3rd power. 9 times 3x squared, that's going to be plus 27x squared. 9 times 4x is going to be minus 36x. And 9 times negative 2 is minus 18. What's really cool about this problem is that there's no like terms. So that is really neat. And by doing the expanded FOIL, I have it all, every single term represented, and it ended up being kind of an easier problem as a result, which is kind of cool. All right, please go ahead and pause the video and do examples 5, 7, and 9 on your own. When you have an answer, please restart the video and we'll see how well you did. All right, for time purposes, I did these problems on a separate sheet. So let's go ahead and see how well you did. Hopefully you combined your like terms and you were able to get 9x to the 3rd power plus 5x squared plus 4x minus 5. For number 7, hopefully you were able to see that the 3x squares, the 4x's, both of those cancel away, leaving you with just the expression of negative 2 minus 7, which is negative 9. And finally, you could have made a 3 by 3 table to multiply these two polynomials together, or you could have done an expanded version of FOIL. And regardless of your approach, you should have ended up with a 9x to the 4th power minus 24x cubed plus 31x squared minus 20x minus 14. Now, if you found that you made a small error, that's an okay thing, but if you found that you made big errors, make sure that you email me so that we can address whatever misconceptions that you have. All right, the next part of this video lesson is going to be on patterns and shortcuts that you guys have already been exposed to. The first one is difference of two squares. We also call it dots. And if you are ever multiplying two parentheses where the values inside of those parentheses are the same, but the only difference is there's a plus sign or a minus sign between them, then your result will automatically be a difference of two squares. Let me show you what happens. A times A would be A squared. A times negative B is minus AB. B times A is once again plus AB. And B times negative B is minus B squared. These two terms that are alike would cancel away, so you would have no center term, leaving you with A squared minus B squared. So essentially, you're going to take the first term and square it, the last term, square it, and put a subtraction sign in between. You'll end up with a difference of two perfect squares. The next one is called the square of a binomial. That's A plus B squared. These will result in perfect square trinomials, PSTs. So PST, if you see an A plus B squared, that means that we would take A plus B and multiply it by itself twice. Do not distribute the exponent. Whatever you do, do not distribute that exponent. All right, a times a is a squared. A times b is plus ab. B times a is once again plus ab. And b times b is plus b squared. Your result is a squared plus 2ab plus b squared. So the shortcut is that you take your first term, you square it. You take your last term, you square it. The middle term is multiplying a times b and then doubling it. That's the shortcut. The same is true as if you had a minus b squared. The result is going to be a squared minus 2ab plus b squared. The sign of b of your middle term is always going to be whatever the sign of your parentheses was. So we're going to use these shortcuts to come up with our answers very quickly. So the very first one is a dot, and we can tell that because the terms are the same. What's different is that one has a minus and the other has a plus. So being able to recognize that the answer will be a difference of two squares will save you so much time. We're going to take 5y and we're going to square it, subtracting it from 3 and squaring it. This is 25y squared minus 9. You do not have to show this work. The only reason why I showed this is to show you what's happening here. Example 11 is another dots. 3 times 3 is 9, so this is 9h squared. 7 times 7 is 49. This is a difference of two squares, so we put a minus in between them. Example number 12, we have a 4a plus 7 squared, which means that we're going to end up with a perfect square trinomial. So the shortcut is we have 4a squared, which is 16a squared. Our sign in the middle is going to be a plus. Our last term we know is going to be 49. And what goes in the middle is 7 times 4, which is 28. 28 times 2 is 56a. So how I got this is I went 4 times 7, which is 28. And it was 2 times 28a to get that answer. There's my answer. Over here, number 13, this is in function notation. We have let f of x equal 9x minus 2, and we want to find f of x squared. So what we're really trying to find is 9x minus 2, that quantity squared. So once again, this is going to be a PST. 9x squared is 81x squared. 9 times 2 is 18. 2 times 18x, that is equal to 36x. So I'm going to write minus 36x. 2 squared is 4 plus 4. One thing you have to know about perfect square trinomials is that this last term is always positive. It will always be positive. We have 2 more examples and then we are finished with this lesson. So for number 16, what we want to do is we want to take this figure's volume and write it as a polynomial in standard form. So the volume of this pyramid is 1/3 capital B times H. And capital B, once again, represents the area of the base. H represents the height of your pyramid. And that's exactly what we have inside of here. We are not interested in slant height. As you guys recall, slant height corresponds with surface area. So that is not something that we're going to be working with, just regular height. And you can tell that because there's a perpendicular inside. So I'm going to write volume is equal to 1/3 times the area of our base, which our base is a square. So that is 2x minus 3 squared. 2x minus 3 times 2x minus 3. And then my height in this case is 3x plus 4. So because this is a parenthesis squared, we are allowed to use our shortcut. So I'm going to write v equals 1/3 times, we have 4x squared, 2 times 3 is 6, 6 doubled is 12, so minus 12x plus 9, 3 squared is 9, times 3x plus 4. Now, if you want to distribute the 1/3, you can, but what I'm going to do is deal with the fraction at the very end. So I'm going to do an expanded version of FOIL, and I'm going to multiply 4x squared times 3x to get 12x to the 3rd power, 4x squared times 4 to get plus 16x squared, negative 12x times 3 to get minus 36x squared, negative 12x times 4 to get minus 48x, 9 times 3 to get plus 27x, 9 times 4 to get plus 36. I'm going to combine my like terms vertically. So I have 12x to the 3rd power. 16x squared minus 36x squared is minus 20x squared. Negative 48 plus 27, that is minus 21. Minus 21x, and then we have plus 36. Now I need to get rid of my parentheses by distributing the 1/3 to every single term. So 12 divided by 3 is 4x to the 3rd power. 20 divided by 3, I'm simply going to leave as negative 20/3 x squared. 21 divided by 3 is minus 7x, and 36 divided by 3 is 12. Here is my expression for volume. Volume is equal to 4x cubed minus 20 over 3x squared minus 7x plus 12. And our last example that pertains to geometry again says find a polynomial expression in standard form for the area of the shaded region. So as you guys recall, the area of the shaded region is equal to the area of the whole region minus the area of the unshaded. So it's the area of the shaded equals the area of the entire region we're talking about, and we're going to take away the unshaded, so therefore you'll be left with the shaded. So our whole area, the area of the shaded, which is what we're looking for, is equal to the area of the whole region, and in this case we have an x plus 1 times an x plus 1, which is an x plus 1 squared, minus the area of the unshaded, which is simply going to be 5 times x minus 7. This is a PST, so I can use my pattern to come up with x squared. 1 times x is 1x, doubled is 2x, so plus 2x, plus 1, minus, I'm going to distribute that minus 5x to each term. Negative 5 times x is minus 5x. Negative 5 times negative 7 is plus 35. I am now going to combine my like terms, and I end up with x squared. 2x minus 5x is minus 3x. And 1 plus 35 is 36. So x squared minus 3x plus 36 is our answer, as well as the end of this video lesson. Hopefully adding, subtracting, and multiplying polynomials is relatively easy for you, but if you are struggling, please make sure that you have a conversation with me or email me as soon as possible. I hope you have a wonderful day, and I'll talk to you soon.